Okay, let's get started here with 1.5a, and this will be the last of a two-part section. 1.5 is the last section of Chapter 1. So we'll do 1.5a, next class 1.5b, and that will wrap it up for what we're going to cover here in Chapter 1. So we're dealing with radical equations, equations quadratic in form, absolute value equations, and factorable equations. We're going to do the first two here in 1.5a. So radical equations and equations quadratic in form. So radical equations, what are those? Those are equations that have roots in them, either square roots or cube roots, things like that. All right, so first type of problem we're going to have to deal with here is if we are solving and the x is trapped underneath a radical. So what we want to do first is get the radical all by itself. So let's move the 2 to the other side. So we have 3x minus 1 equals positive 2. And then what cancels out a cube root? Cubing both sides. So 3x minus 1 equals 8. And from there, we're going to solve it algebraically like we normally would. 3x will be 9, so x equals 3. And we could go ahead and check this. The cube root of 3 times 3 minus 1 is the cube root of 9 minus 1, which is the cube root of 8. Which is indeed 2. And if we said minus 2 to all those things, like in the original, we get 0, which is what it's supposed to equal. All right, so for the first problem, the one you're going to try, problem 11, go ahead and isolate your radical, and then square or cube or whatever necessary to get rid of the root. All right, second example. What happens, so same strategy here, but what happens if you have a multiple term on the other side? Binomial, trinomial, whatever. Well, how do we get rid of the square root symbol, the x plus 1? We're going to need to square it. If you square one side, you need to square the other side, which means foiling. The left side comes out as just an easy x plus 1. The square root and the square cancel. On the left side, if we foiled this, negative x times negative x is x squared minus 2x plus 1 is what you would get from foiling it. Let's get everything on the same side and solve it using our factoring quadratic formulas here. So x squared minus 3x, and the 1's are going to cancel out. That's nice. So now we can factor out an x. We'll have x minus 3. And so x will either equal 0, or x minus 3 will equal 0. So x is 0, or x equals 3. And if you plug this back in, we could check this. The square root of 0 plus 1 equal negative 0 plus 1. And so the square root of 1 is equal to 1. That checks out. Let's try it with 3. The square root of 3 plus 1. Is that equal to negative 3 plus 1? Is the square root of 4 equal to negative 2? And it is, because the square root of 4 is going to give you plus or minus 2. So we would get the negative there. So that one checks out as well. Pause the video. Try problem 23. Okay, now what happens if we are adding or subtracting radicals from each other? This gets a little tougher. This is going to be a two-parter. You're going to have to square twice because there's two radicals here. All right, so what I'm going to recommend is get the more complicated radical. And this one, the more complicated is going to be 5x minus 1, just because it has two parts. Get that on one side, get everything else on the other. Square root of x plus 1. We're going to square both sides. But on the right, that means foiling. So the left comes out nice and clean. The right, square root of x squared is x, plus 2 root x, plus 1. We've squared, but we're still left with a square root. So now we're going to follow the same steps we did on the previous examples. Get that square root by itself. Let's get everything on the right over to the left. So we'll have 4x minus 2 equal to 2 root x. And let's divide by 2. You don't have to. We could square both sides right now. If we did remember to square everything, But since we can divide everything by 2, let's clean it up. 2x minus 1 equals the square root of x. And now let's get rid of that square root symbol. We'll square both sides, and we'll get 4x squared minus 4x plus 1 equal to x. Let's bring that x over. 4x squared minus 5x plus 1 equals 0. This is not going to factor out, so we're going to go, let's see, would it? Maybe a 4x and a 1 and an x and a 1. Hey, there we go, that'll work. Minus and a minus. And so x, that's still equal to 0. X will equal 1, or x will equal 1/4. All right, you can plug that back in and check, but those are the correct numbers. Let me check my work to make sure that's what I got before. And the answer is 1 or 1/4. Yep, there it is. So, key on this one, these are kind of tedious because you have to do it twice. You're going to square once to get rid of the first square root. You're going to move everything around down here, and then you're going to square again to get rid of the other square root. Two-parter. All right, pause the video, try problem 31. Okay, second objective, last objective for this video. We're going to solve equations quadratic in form. You know what that means. We're looking for A, B's, and C's for our quadratic equation. Okay, so for the first one, now the first one is going to be the easier version because this one actually factors. Don't need to use the quadratic on this. What we see here is something squared, something to the first, and then a constant. This is like our old a squared minus 3a plus 2, and that's actually what we're going to do. We're going to use these placeholders. Put in an a instead of x minus 2, an a instead of your x minus 2, and then does this factor. Sure it does. This is a minus 2 and a minus 1. That's equal to 0. All right, forgetting about the x minus 2 for a second, let's solve for a. A equals 2, or a equals 1. But in this problem, what does a equal? A is actually x minus 2. So in this problem, x minus 2 equals 2, or x minus 2 equals 1. We're using substitution. X equals 3, or x equals, 2 plus 2 is not 3. X equals 4, or x equals 3. And that's what you should get for that problem. All right, so we'll have a couple like that to do in our practice, but for now, let's go look at the harder one here. So the harder one here is x minus 5 root x plus 6 equals 0. We're going to try problem 51 after this. Here's how we're going to go about this. We're going to solve this using the quadratic equation, using our a, b's, and c's. But instead of normally our quadratic equation is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. You almost got me to sing the song this time. Not quite ready for that. Since this is not x like it normally is, since it's square root of x, square root of x is going to equal the negative b, all the quadratic equation. Let's go ahead and solve it. Square root of x is negative 5 plus or minus the square root of 5 squared minus 4 ac all over 2a, which is just 2. So we got 5 plus or minus 25 minus 24 is just 1 all over. Oh, yeah, no, that's right. Sorry. I was thinking I was doing a different problem. Square root of x is 5 plus or minus 1, which is either 6 over 2 or 4 over 2, which is either 3 or 2. But that equals the square root of x. We want to solve for x. How do we get rid of the square root? We need to square. So x is either equal to not 3, but 9, or not 2, but 2 squared. 4. X is either 9 or 4. All right, those are your two solutions. That's how you're going to solve this. Use the quadratic equation for root x, and then square your answers. All right, 51 is yours to try. Get that done, and you're all set. Any questions? We'll go over them in class. Good luck.